Okay, welcome to anyone. So we can start. We are in the section on unlocking the potential of digital technology for a sustainable energy transition. We have with us some speakers from different organizations. We have Chi from is our acting chairman from ITUT Study Group 5 from CACT China. Xia Wang from as program officer from UNEP. Vida Rosait is a program manager of International Energy Agency, and Claudio Bianco, that is an environmental efficiency engineer from Telecom Italia from team. I am Paolo Gemma. I am the chairman of ITUT Working Party 2, dedicated to energy efficiency and circular economy. And it's a pleasure to welcome all of you from any part of the world to this workshop. And okay, just to start, I give the floor to Madame Chi.
Thank you very much.
And if you can share the presentation, I have no idea. I hope it is working.
If you allow me to give opening remarks, some words, I think I would like to open first. And ladies and gentlemen, good morning, good afternoon, good evening. It is my pleasure to welcome all of you to our events today. And to begin with, I want to thank Vienna Energy Forum for collaborating with ITU in organizing this side event. And also, digital transformation is a powerful tool that is having profound impacts across the energy sector value chain, and from optimizing grid efficiency and aggregation for renewable energies to supporting the process of carbon capture and storage. Digital technology are bringing new and exciting opportunities for the energy sector to tackle global challenges such as sustainability and climate change. The energy sector also plays a key role in achieving Sustainable Development Goal 7, ensure access to affordable, reliable, sustainable, and modern energy for all. Its importance is reflected in the United Nations high-level dialogue on energy that will be held in September, and the ministerial thematic forum that will take place at the end of June. ITU has also had the wonderful opportunity to participate in the technical working group 4 on innovation, technology, and the data that will contribute to high-level dialogue on energy. However, there is a lack of focus on the environmental cost of developing digital technology, and the lack of discussion on the sustainability aspects of digital transformation. Information and communication technology is one of the key enablers of digital transformation. The ICT sector currently accounts for roughly 1.4% of overall global emissions, and the sector uses about 3.6% of the global electricity for its operation. Meanwhile, digital transformation continues to impact the energy sector and beyond. The global pandemic has only further accelerated this process. If you are to fully realize the potential of digital technology in accelerating the energy transition and supporting the achievement of fully realize the potential of digital technology in accelerating the energy transition and supporting the achievement of SDGs, we need to take into consideration the sustainability aspects of digital technology and incorporate it into the global energy transition process. ITU is the United Nations specialized agency for ICT. So in this, based on this, ITU has been working closely with its diverse membership to develop inclusive environmental standards and support the ICT sector to achieve net zero emissions, improve energy and environmental efficiency for ICTs, and the shift towards the circular economy. Our green standard have also provided the means to access the sustainability of office building and the intelligence building services. However, the energy transition is extremely complex process and no one can do it alone. Open discussion and the collaboration are also the keys to achieving a sustainable energy transition. This takes us the objective of today's panel. So today we will taking a closer look at how we can improve the sustainability aspects of digital technologies and the steps that we must take in order to achieve a sustainable energy transition. Without further delay, I will give floor to our manager, Mr. Paolo Gemma, who will be our manager of this session. Thank you very much, Paolo Gemma, and the floor is back to you now.
Okay, thank you, Chi. Okay, now we will have your presentation about Study Group 5 work. You can share.
Yes. Can you see my screen?
It's arriving. No. No, we see you. Not the presentation.
It seems that you see me. Oh my God. Let
now
me
it's arriving.
check.
No, it's arriving. Okay, now it's okay. Now
it's
we
good.
see your
You can see my screen?
Yes.
Ah, good. How about this?
Yes, it's okay.
My
it's
screen
okay. It's working.
Working. Good. I'm lucky. So my presentation is titled "The Role of International Standard for Sustainable Energy Transition and Achieving Net Zero," and it includes how international standards help us. For example, you can see here: reduce carbon emissions, achieve a sustainable digital transformation, and improve undertake of energy, green energy, and achieve targets set in the Paris Agreement SDGs. And also you can see practical guidance to implement green energy solutions and provide measurement tools to evaluate process and bring low-cost connectivity to rural areas and also reach net zero goal. So for ITUT Study Group 5, we have developed the international standard, and we also open the research work and the pre-standardization work, and we are raising awareness of new hot topics, and also we are pushing towards the active collaboration. In ITU, we have consist of 193 member states and over 900 companies, universities, and international and regional organizations. So this is a very big international platform, you can see. And here I would like to just to share one recommendation ITUT ILO 1210, which is the sustainable power feeding solution for 5G network. You can see from the figure that which was on the right top, the energy consumption of the base station will be increased to three times than 4G. And we have some power feeding solution in this recommendation that based on the 5G C-run and the D-run mode, we have a different power feeding solution to solve the energy consumption and also push forward the energy saving solution. And here you can also see the we have put some peak shaving solution in this recommendation and also renewable energy solution, but not only directly, but also how we can use ICT technology to use more renewable energy. For example, we set some values higher than the grid voltage value, then we can use renewable energy as much as possible. Then we have series of ITU standards on smart energy solutions. We have, you can see here, we have ITUT ILO 1380 is smart energy solution for telecom sites. And we also have a smart energy solution for data centers and telecommunication rooms. In this recommendation, we have considered how we can use the green energy and also using ICT technology to control, smart control to get higher energy efficiency, not only for one equipment, but also for base station, whole data center, and also whole network. This is ICT can have some influence or how to say improvement on the whole and network level. And we also have pretty new one in 2020 this year, 21 this year May meeting, smart energy solution for cities and the home application. This was approved during the plenary, and now it is the draft and in AAP process. We have here smart energy application in a residential community and also in business buildings, industrial parks. And we also have smart energy solution for home and also home equipment, etc. This is the promoting from the whole city and from a home application to have the smart energy and also increase the energy efficiency and improve the clean energy input. And just for your information, we have also sustainable and intelligent building recommendation, which is you can see here on the screen. Sustainable and intelligent building services define the key concepts and the minimum requirements of sustainable intelligent building, and also define the functions and the requirements of IoT nodes in buildings. And another one is we have ILO 1371, a methodology for assessing and scoring the sustainability performance of office buildings. This recommendation specifies a methodology for assessing and scoring office building and includes best practices to improving energy efficiency in buildings. Then we have series of recommendation for your reference standard on environmental impacts and the net zero. You can see on the screen that ILO 1400 series. First one is 1400. Overall and the general principles for methodology for assessing the environmental impact of ICT technology. And 1410 was methodology for environmental life cycle assessment of ICT technology goods, network, and the services. 1420 was methodology for energy consumption and the GHG emission impacts assessment of ICTs in organization. And the 1450 was methodology for assessment of the environmental impact of ICT sector. And the 41 is the ICT in other sectors. And we also have very famous one, ILO 1470, which is the GHG emission trajectories for the ICT sector compatible with UNFCCC Paris Agreement. And we have two supplements for this recommendation. One is for operators and another is for manufacturers. And we have also a new one in the May meeting. During the May meeting, we approved recommendation on guidance and criteria for ICT organization and on setting net zero targets and strategies. So just for your information that for working party 2, for strategy group 5, environment, energy efficiency, and the circular economy, Paulo Gemma is chairman of working party 2. We have 6 different questions you may be interested. First one is environmental efficiency for digital technology. Then we also have another one, e-waste, circular economy, and the sustainable supply chain management. And the question 9, they are working on climate change and assessment of digital technology in the framework of SDGs and the Paris Agreement. 11 is working on climate change mitigation and smart energy solution. 12 is adaptation to climate change through sustainable and resilient digital technology. And then the last one is building circular and sustainable cities and the communities. I think this is all for my presentation, and please contact TSB or myself if any clarification needed. Thank you very much. Floor is back to you, Paulo.
Thank you very much, Chi. Just to inform the people that we have question and answer session at the end of all the presentation, and in any case you can put a question on the Q&A part just to put your question if you want to ask something to our panelists. The next it will be Xiaowan from UNEP. I don't know if you can share your presentation.
Right.
Okay, yes, it's working. We are looking.
Okay, because I can't see anybody. So, but thanks for inviting me to this panel. So today I'll be talking about sustainable energy transition through energy efficient data centers. And since I would assume some of the participants is not from the digital infrastructure sector, so I will try to provide some basic overviews of energy efficient data centers and sustainable energy transition of digital infrastructure. So I will be covering a few questions. What is a data center, and why do we need to address data centers when we talk about sustainable digital technologies? What are the energy and environmental impacts of data centers? And what are the energy efficient and environmental efficient solutions we can use to decarbonize data centers and the digital infrastructure sectors? So first of all, what is a data center? A data center is a dedicated building or a separate room which houses the technology for data processing, data storage, and data communication of one or more organizations. So this facility is exclusively used to place the IT equipment like servers, routers, as well as the power and cooling infrastructures. And that is within the data centers. And outside of the data centers, there comes with the power supplies, bandwidth connectivity, security systems, and the control of the overall management of the buildings. So data centers comes in different types and shapes, and there's no consensus in how can we characterize data centers. But here I have provided two ways in looking at data centers. The first one is by the number of servers, by the sizes of data centers. And on the graph, you can see data centers can be as small as a facility where it contains less than 500 servers, or as big as the hyperscale data centers, where it contains more than 10,000 servers. And there is also another way of looking into data centers, which is the business models, operational models. So we have tried to characterize them into four big categories. For the first one as the in-house, which is also called the on-premises ones, which are normally the organization's IT department taking over the responsibilities of managing the IT infrastructure. And the second one is the co-location. This one is probably the most known ones to us, where other commercial providers build and own the facilities and rent out the space. They normally guarantee the security, connectivity, power supplies, and the resilience of the facility. And the third one is the hosting. Commercial providers provide different managed services, and normally they will lease all the IT hardware. And the last one are the cloud data center operators. They will build and run the data center themselves and provide the software application services to the customers. But data center is only one part of digital infrastructures. And what exactly is a digital infrastructure? There is no unified terminologies of digital infrastructure, but here I have cited the ones provided by the Asian Infrastructure Investment Bank. So for them, digital infrastructure is defined as one integrated system, which is composed of two parts, the non-physical parts and the physical parts. And the digital technologies we're talking about today falls into the soft digital infrastructure, which are the services and applications that create economic value add to the business sectors and the consumers. And the data centers I'm talking about today falls into the hard digital infrastructure, which is the storage and processing. And it is very important to understand digital infrastructure as a concept because it is the foundation of our digital economy. Now, how does data centers relate to the digital applications technologies? On the graph placed at the bottom of the right corner, we can see there is a housing animations. And out there, we can see the digital technologies is mutually reinforcing with the traditional infrastructure sectors, which are using the digital technologies, we can improve the effectiveness and safety of the transport sectors. We can improve the water usage efficiencies. But all the digital technologies can only make sense if we interlink them through the network, which is the lines that above the entire house. And if we look into the bottom of this house, we can see that is the foundations of the entire digital ecosystem. And these are the data centers we're talking about today. And they are the ones supporting the locally deployed digital services and the growth of the local digital ecosystems. And because of the growth of the digital economies, so are the data center industry sector is growing exponentially. And I have some numbers on how much the digital sectors, the data center is growing. It is estimated that in 2021, there will be 7.2 million data centers in the world, storing about 1.3 exabyte of data. And this represents nearly an 8-fold increase in the amount of stored data compared to 2015. So what does it mean with such a high growth of data centers to the energy transitions? I have provided some data where I cited from a Nature article, and according to this article, data centers use estimated 200 terawatt hours each year, and this is more than the national energy consumption of some countries, and half of the electricity used for transport sector globally, which accounts for 1% of global electricity demand, with data centers contribute around 0.3% to overall carbon emissions. And comparing to the entire information and communication technology ecosystem as a whole, it is consuming around 2% of global emissions. And that will put the entire ICT's carbon footprint on a par with the entire aviation industry's carbon emissions. What could happen in the future is really hard to predict, but one of the worrying studies shows us that the electricity used by the ICT sector could exceed 1/5 of the global total, with data centers using more than 1/3 of that in 2 decades' time. And if the computationally intensive Bitcoin continues to grow, that we could say that these energy demand would come sooner rather than later. So with such a huge energy intensive industry, we probably want to know where exactly are the energy being consumed within the data centers. And in figures 3, I provided a share of energy demand by different components in data centers globally. And on this graph, you can see most of the energy comes from the IT equipment, with servers taking up around 56% of energy consumptions. And not to mention that most servers run below its maximum power capacity during the data center's operational time. And the second position comes in the infrastructure energy demand, with cooling infrastructures consuming most of it. And the third part is the storage energy consumptions, which are mostly hard disk and solid state technologies, with the last one on the network counts for around 2% of the energy demand of data centers. But data centers' impact do not only stays with energy part, there's also comes with environmental part. And I want to look into the environmental cost of data centers through the lens of environmental impact analysis. On the graph I've selected here, we can see that the concerns of data centers' environmental impacts, apart from the carbon emissions, there are also the air pollutions and resource efficiency concerns. Among all of these major concerns, there are 2 concerns I want to mention here. And the first one is about the e-waste. So the e-waste is created when the data centers dispose their IT storage network equipment, and that will create deposition of heavy metals and hazardous materials into our landfills. And there are studies being done showing that 3/4 of data centers are refreshing their systems in 5 years or less, and companies more than $1 billion in size was twice as likely to refresh systems every year and to dispose of hardware without recycling than smaller companies. Based on this observation, an estimated 20 to 50 million metric tons of e-waste is disposed of globally every year. And if measures are not taken, then e-waste is expected to grow around 8% each year. And the second concern I want to talk about is probably is not receiving as much coverage as the carbon emissions and e-waste is about water usage of data centers. So there are around about two main categories how data centers consuming water through the direct cooling infrastructures and through indirect electricity generations. And even though data centers, the amount of water data centers consume is rather small compared to the national figures we can see on the water demand, but the data centers do compete with the local users on these resources. So how much exactly a data center consumes on water? I have some numbers for you. A medium-sized data center around 50 megawatts uses as much water as 3 average-sized hospitals or more than 2 golf courses. And data shows that some of the data center operators are drawing more than half of their water from potable and drinkable sources, and less than a third of data center operators measuring their water consumptions. And that's really bringing us alarming concerns. The lack of data will prevent us from monitoring the environmental impacts of data centers. So how do we go about that? And there are different ways to analyze the data centers to provide a 300 degrees views on environmental impacts of data centers. And life cycle assessment is one of the ways to quantify a large variety of environmental impacts of data centers, because this life cycle of data centers covers from the raw material extractions to the manufacturing of components to the transport, operational state, and also to the end life of data centers, such as the e-waste and energy recovery. So the inclusion of the entire life cycle of data centers is very essential to prevent environmental burden shifting from one life cycle stage of the system to another, or from one component to another. And if you want to hear more, we have produced a technical brief of life cycle assessment and multi-impact perspectives for data centers, and you can find that at c2e2.unepdtu.org. So after we have mentioned all the problems, what can we do? What are the ways to solve these problems? The first one, I want us to look at energy efficiency strategies in responding to the energy demand areas we have just mentioned, where it comes from the cooling, IT part, and electricity uses. And here we have designed listed a few energy efficiency solutions for that. Like you can consider to use upgrade to more energy efficient IT equipment or more efficient power supply that will help you to save both the capital and operational cost. And on the cooling side, besides redesign air management, there are also like innovative cooling technologies one can consider to adopt. And one of these innovative cooling technologies, liquid cooling, I want to mention here. And liquid cooling is to using the cooling liquid to exchange heat with the components that's in a liquid circuit, which proves to be very effective, improve energy efficiency in data centers. And if you want to know more about liquid cooling technologies in data centers, we have also produced a technical brief on liquid cooling technologies in China, which has been commercialized in the private sector. And you can find it on our website, c2e2.unepdtu.org. So apart from the energy efficiency solutions, there are also other ways to tackling the environmental efficiency of data centers. And here I have cited the graph from the European data center industry, where they have designed this to reach their ambitious plans to reach European data centers climate neutral by 2030. To do that, they have identified a few areas beyond energy efficiency solutions with measurable targets. They have also identified with the renewable energy power supplies to purchase 100% carbon-free energy, as well as prioritize water conservation to improve water usage efficiency, and the e-waste reuse and recycling, and to reuse and repair servers, and also to look for ways to recycle heat through the waste heat recovery. But last but not least, I want to mention that if we really want to solve the problems that about data centers proposing to the sustainable energy transition, we cannot look into the technologies solely. We need to adopt an integrated solutions to tackle this problem. And that means that policymakers need to establish a robust mechanism for data collection and data sharing. And we need to adopt a multilateral collaboration approach to engage the private sectors for industry standards developing. And we also need to adopt an inclusive mindset for policy making that needs to consider the developing countries' needs to help them to build digital skills and capacities. So that is my presentation. Thank you very much. And you can find many more related knowledge products on our website around digital infrastructure.
Paolo, you're muted. We can't hear you, Paolo.
Sorry. Thank Xiao. Now the next speaker is Vida. I invite the people to put the question on the Q&A panel, in which also the speaker can answer directly, or we can, in any case, we will answer at the end of the session. Please, Vida.
Thank you, Paolo. And thank you to the other panelists for such interesting and important presentations. So it's a pleasure to participate in this discussion today. And many points have already been covered by Xiao and Ji. So what I'd like to do is to raise a few complementary and additional issues, as well as to reinforce some of the very important things that were previously said. So point one, urgency. So carbon dioxide emissions are on the rebound at a time when millions of businesses have shut down or had to scale down, and when most economies are still experiencing severe economic slowdown. If we look at what's happening in the area of clean energy investments are rebounding, are growing, but they're growing at a very slow pace considered to in comparison to the massive changes that would be needed to be able to reach a clean energy transition. Which brings us to the International Energy Agency's net zero report. So in May this year, we published a report looking at what would it take to reach net zero for the energy sector over the next 3 decades. And what we see there, bringing me to my second point, is unprecedented scale and scope. So if we would just break down these numbers a little bit, just to provide some illustrations on the order of magnitude. So today we have around 11 million electric vehicles on the road. According to this net zero scenario, we would need to reach 2 billion over 3 decades. Similarly, buildings with residential solar PV, today at around 25 million, would need to leap up to 240 million over the next 3 decades. Similarly, heat pumps at 180 million installed today to 1.8 billion by 2050. And at the same time, of course, a massive ramp up of energy efficiency. So what we're looking at is a large number of distributed energy resources that will be coming in to the power systems. At the same time, we're facing the challenge where we're electrifying end users. At the same time, we would be looking to increase variable renewables and phase out traditional sources of flexibility. So flexibility sources are the resources that make sure that when demand surges, we don't lose our electricity supply. So this brings us to my third point, that in the clean energy transition, electricity systems, and in particular distribution systems and demand side resources, are set to be at the absolute center. And if we look at this graph, we see that there's a massive increase in the need of new flexibility resources. And these are many of them, these distributed resources. And there's absolutely no way these can be tapped or utilized in an effective way without a large-scale deployment of digital technologies. And so these are technologies in transmission systems, in distribution systems, substations, to the end-use equipment and assets in people's homes. And this, of course, opens up a myriad of challenges, especially here focusing on, if we look at all these things that need to be connected, they need to be controllable, they need to be able to interact with each other. We need interoperability, and we need interoperability that can work across systems. And here, of course, international standards play an absolutely crucial role. And then if we move on, looking at sort of the investments needed. And we see on the left-hand side, investments in power systems increasing at an extremely modest scale. And then if we look at our different scenarios, so the STEP scenario, that's the stated policy scenario, so the base case around what's happening now, the SDS, that's our sustainable development scenario, so increasing the climate ambitions and environmental ambitions in that one. And then finally, the net zero emission scenario, where we see a massive ramp up of investments needed. And here again, there's a potential role for digitalization, as digitalization can unlock new business models and can also enable us to utilize assets much more effectively and efficiently, to cut down on losses, and to also avoid needing to build out hard assets, but leverage existing assets to provide flexibility and grid services. And so here, just to highlight some of the things that the IEA is doing in this space, we have started up a multi-year cross-agency initiative with the support of the Italian government to explore how digitalization can support clean energy transition, with a focus on developing actionable policy guidance. And another aspect that I'd like to introduce to this discussion is, sorry, my presentation seemed to have failed. Give me a moment. So what I wanted to introduce is the social dimension. So we have a global commission looking at the social dimensions and people centricity of the clean energy transition. And if we're looking at such sort of wide-scale involvement of people, of residences, of homes, of businesses in the clean energy transition, then we do need to consider aspects such as users. Apologies, system is glitching. So just to wrap up, so the social dimensions, we do need to consider acceptability of digital technologies. We need to engage in communication about the value these can unlock, consider, of course, data protection, and ensure that consumers are consulted, but also ensure that this digitalization doesn't contribute to the digital divide, where only those that are connected or have these digital skills are able to access the benefits that these opportunities can unlock. And similarly, that we don't cut off other communities and parts that are unable to access digital services, as well as considerations to the changes that will happen in the employment market and the need for upskilling and reskilling. So a final slide that you'll have to imagine, just again, revisiting many of the important points that Sao was mentioning around the need to think about the risks, and not to think about risks and challenges as an afterthought, but to think about now, once we're looking at a massive large-scale deployment, to see that we do not cause excessive damage to the environment. And as I mentioned, the social dimensions are extremely important to consider. There's a need for very robust data management and protection frameworks and transparency around data, how data is used, who's accessing data and for what purposes. There's a need to look into how to counteract both the indirect and the direct energy demand of ICT equipment. And this is a continuous process. What we've seen in the past years is that ICT equipment has increased significantly when it comes to efficiency. But then if we're looking at a wide-scale deployment, there's an even greater push needed to get to even higher levels of efficiency. And similarly, as I was mentioning, the whole issue of electronic waste and the need to look into what are the options to ensure circularity, asset and equipment repairability, the possibility to upgrade, what are the implications if everything increasingly becomes connected? Well, what does that mean for product lifetimes? Will we have to discard products at a much higher rate and buy new ones, or are there ways to upgrade continuously and thereby save important resources? And of course, as was also mentioned, the equitable access to technologies across all nations and all countries, and a significant opportunity there to work on an international scale to improve access, and especially access to products that are affordable, that enable countries to take advantage of digital technologies for sustainable energy transition, but without prohibitive costs, without proprietary platforms that limit their development. And then, of course, importantly, cyber resilience. And as we've seen in the news, attacks across countries, across companies are increasing, and we also see an increasing incidence in the energy sector. If we're looking at a more distributed system where masses of assets across homes, businesses are being connected to the system, safeguards do need to be in place. And again, there are opportunities to work on an international level, as well as support through the development of standards and protocols. So with that, thank you very much for having me in this discussion.
Thank you very much, Vida. The next speaker will be Claudio Bianco from TEAM. Please, Claudio, if you can share your presentation. And you are muted.
Yes, Paolo, welcome. Good morning, good evening to all. Thank you for invitation and for this interesting opportunity to share knowledge and experience. I will share my desktop. I guess you see it?
Yes, we see it. Yes.
Okay, so I take my 5 minutes. I will go quite quickly. I think the purpose of this meeting is also to share through the presentation information that we can go deeper after the meeting. So from an operator point of view, what I can say that we know as from JESI study, Global Enabling Sustainability Initiative, you can go on this web. We know it's one of the main initiatives running, but this figure is something I like to put down. ICT, as you can see on the bottom of the figure, we are a part of the problem. We have a footprint, so we have to manage. These figures are past figures, but we can update. I didn't have time to update, but we have seen some figures from the colleagues Xiao Wang that forecasted that we have to work on this. ICT is a part of has an impact, but can enable, as you can see in this upper part of the figure, can enable several savings on several sectors. So, standardization is for sure something we have to push. ITU is helping us on this. So my appeal, my request is all you attendees to this meeting, please also work on the standardization area. So double face of the money, part of the problem, but also we can enable a lot of savings and improvements. If we go to to the next slide. To the next slide, you can see this is a quick slide about what are networks. I come from network department, so as you may know, we have hardware and software parts to develop. For sure, the network is fundamental to reach the targets. We have fixed networks, mobile networks. Here are some figures and some references you can go through to have deeper information. I just wanted to visualize full screen, but I don't know what. Okay, I will go on like this because I don't find the full page. Okay. In this slide, I share the hot topic we have running, that is 5G deployment of the network. 5G is one of the tools we can use to have a smarter services and to enable new improvements also in the energy and environmental transition. Here you find some characteristics of 5G: enhanced mobile broadband, massive machine-time communication, and ultra-reliable and low-latency communication. These are the three main features of this technology. Here you find also some figures that are going around and that are becoming and will become more and more usable. I think these are tools we have to keep in mind to give improvement to the contribution of using ICT networks and services to push energy transition. In this slide, I got from a specialist sector. You find, for example, 5G and other technology where can help. Obviously, there are different sectors. There is waste management, air and water quality monitoring, energy, building structural remote monitoring. As we said before, buildings are responsible of a lot of energy consumption, but you can see that obviously these technologies can help us also on other, say, on safety, on smart road, vehicle 2X topics. In this area, for example, on the energy demand response topic that was quoted before by the other speaker, there is a forecast also to use batteries of electrical cars to exchange energy with the grid for demand response. This is one of the possibility. I don't know why I go back, but this slide is something commercial. I mean, we have examples of something that is running in Telecom Italia, but really operators with the help of manufacturer are working on self-driving car, drones, e-health, virtual reality. And also this slide is self-explicative, but I wanted to share with you because from operator point of view, I think we have different levels. We have the network, sensor and smart devices, where we get the cities, the buildings, the infrastructures. Then we have a network that connects in a second level that connects to the platforms and to the application domain, so the cloud domain. This is the data center domain that was depicted before. So we have data information coming up from the world and coordination and action coming down, and this is a circular. It's as a Telecom Italia, we have a lab where we develop these solutions, and we have already a commercial platform that it's available for customers. This is Turin-based. I hope one day I can invite you to visit. Then there are some quick slides. I will do a flight on it. You will find the presentation, so you go. There are also links. Obviously, artificial intelligence is something that is coming. There is a story of artificial intelligence. and is ramping up. It will become more and more pervasive, the usage of artificial intelligence, and also for energy transition, environmental transition. I am sure it will be fundamental. This is another example of usage of artificial intelligence in mobile network. You find some references here. And also this is a usage of mobile networks to have information from the network. This is a part of Italy. These slides makes me to think about climate change and adaptation to climate change, as Chi Shudung stated at the beginning. Also, ITUT is working on this topic, not only ITUT. This is also an important part to take advantage of standardization and work for this. Blockchain is another technology we have to keep in mind. And I close with this last slide in which I put together some keyword. Beyond connectivity is a motto we have started to use in Telecom Italia to say that we have need of network. Obviously, they must run and work, be resilient, reliable, and resilient. But we need also services, cloud and edge computing level. And that's all from my side, Paolo. I give you back the floor. Thank you.
Thank you, Claudio. So we can start with a question and answer session. We receive a question on the Bitcoin mining. He said, how do we avoid the pitfall of technology such as Bitcoin mining? This is a very good question for the future. I don't know if some of you can answer to this issue, to this question, sorry, and answer to Jacob. As I try to answer to Jacob, we can, in ITU, we have a focus group on artificial intelligence, on energy efficient artificial intelligence and other technology that we can discuss about this topic. Ensure, okay, we have developed a standard for the efficiency of ICT that can in some way applicable also to this technology. Will be a very big challenge for this due to the cost in reality to implement technology on this type of mining. I don't know if some of you want to add something on this.
Well, perhaps just to complement, Paolo, what you were saying, and that question really brings home the need to work across issues in a systematic, integrated manner. There's a need for improved efficiency of processors, of equipment. There's a need for improved efficiency in data centers, in cloud systems. There's a need for increased deployment of renewables to enable reducing the carbon cost of different types of processing applications.
Thank you, Vida. Yes, this is totally true. We need to work in. There is not only, I think, and I said a lot of time in the past, there is not only one solution that can solve all. It's the sum of some small solution that can resolve the problem. So at this point, if we don't receive other questions, we are just 4 minutes. I like to ask to Chi if he can shortly speak, because he mentioned that as I do, we have working on recommendation and standard on 5G and data center energy consumption. How you think that this standard can help us to obtain the goal of the CO2 reduction? You are muted. Chi? We can hear you. You are muted, Chi. Okay. Okay, maybe okay, we can wait. Okay. Okay, the way that we are waiting Chi that is able to speak, I have a question to Xiao. So this is a very good issue when we speak about renewable energy for power data, for data centers. So if we provide 100% of renewable energy for data centers, so in any case, we need to speak about energy efficiency solution. We need to develop that.
Well, I think if we talk about how to improve data centers, right, as the digital infrastructure sector's sustainabilities, I don't think it's a either or questions in choosing the solutions, and rather both renewable energy solutions for energy efficiencies should be equally explored for their positive returns. Because based on this latest report, emission gap report produced by the UN Environment Program, our world is really facing catastrophic temperature rise in excess of 3 Celsius degrees, which is far beyond the Paris Agreement's goal, like limiting the global warming to well below 2 degrees in pursuit of 1.5 degrees. I think that clearly showed we're not really heading into the good directions, despite all the efforts we have been done. And that really reinforced the messages that all kinds of solutions that will contribute to energy reductions and improving energy efficiencies should be explored. And only by doing so, we will be able to deliver what the climate experts said we should be doing in order to reach the goals to keep our environment and the world safe and sound. And therefore, all of the areas that will provide positive returns to contribute to the Paris Agreement, to contribute to the UN SDGs in improving the digital infrastructures for sustainable energy transitions cannot be overlooked, but explored.
Okay, thank you, Xiao. I see another question on the chat on are there any roadmap for the integration of efficiency in the emerging technology like 5G and beyond, artificial intelligence, etc.? Is roadmap, okay, there is work on this in any standard organization, RTU and other. Roadmap is something more, I said, dedicated to government on pushing on this. Sure, there will be a roadmap for the reduction of the sector, and any technology need to contribute to this reduction. But we can see what we can make on this. And Vida, what do you think that could be the international international collaboration can play in mitigating risk association with this digitalization, including this new technology?
Thanks, Paolo. And there's a role for international collaboration, both in terms of leveraging the benefits that digitalization can bring to power systems. As I indicated in my presentation, that there is a sense of urgency. Xiao was also emphasizing this in her point that we do have an emission gap. We do need to fast track progress. We don't have time to work in silos and to solve problems and challenges on our own. There is a need for collaboration. And similarly, when it comes to the challenges, when it comes to cybersecurity, international collaboration is absolutely essential. As was mentioned throughout this session, international standards, absolutely important to ensure that environmental safeguards are in place, to ensure that industry is aware of environmental impacts and is working in this direction. So definitely, but both in terms of the urgency, but also in terms of the opportunity to develop more effective and more robust solutions. And as was mentioned, the issue with e-waste and recycling and circularity, we do have a situation where waste products are shipped to other countries and to emerging economies to cause havoc in the environment. There is a need to ensure that safeguards are in place and systems are in place to recycle these products and reuse these products in the most sustainable way.
Okay, thank you. Oh, Chi, can you unmute you this time? No. No. No, we cannot hear you. You are always muted. Okay. We will have your answer at the next ITU meeting. Claudio, what is network or service? What is what team think to develop to unlock the potential of this technology for a sustainable energy transition?
Yeah, Paolo, thank you for the floor. I just would say both. I am a network guy. I come from experience related to hardware, to power system, battery backups, infrastructure, and then the core equipment. Obviously, we have to work on that. Also, for the connectivity part, we have to deploy networks capillary going to reach each corner of our country. But obviously, we have also to take advantage of the development on the services, on the software part. So double work to work together. I just want to add that about the question, how can the roadmap for the integration of efficiency in the emerging technologies like 5G and beyond AI, I would add, Paolo, to your remark that I think it's a win-win challenge. As an operator, we need to have efficiency, environmental efficiency, energy efficiency from the design of the technology of the system. Also for the vendor, the manufacturer is an opportunity to put on the market something that will get competitiveness. At the end of the day, the TCO approach, total cost of ownership, I think has to lead the choices, CapEx and OpEx together. We are pushing, personally I'm pushing inside my company this from years. Something is coming out, but I think we have also to follow this path. Efficiency and energy and environmental efficiency by design. There is a strong work on recyclability. You have to design a system that you can disassembly and to reuse, and also on this ITUT is working a lot. So thank you all for this.
Okay, and finally we will have together with us Chi. But,
hello, can you hear me?
yes, now, yes.
Oh my God, I'm so sweet.
Finally,
thank
yes.
you very much.
Just Claudio is speaking to improve network, so it's okay.
We have very good operators, you don't have us to connect. Thank you very much all. And just one word that in ITU recommendation, we have plenty of solutions. You can have a look. And for data center, telecommunication room, base station, and also smart energy application in the cities and the homes. Please just have a look at. Okay, thank you so much, Paolo.
Thank you very much to
for
you,
waiting
Chi.
me.
And I think now is 5 minutes past 12. I think that we can close our session. Look just on the pool and put your answer on the pool, on the 3 questions that are on the pool. The first is introduce which are the key actions required to bring the energy and climate goal closer to reach. The first was introduce government policy to stimulate demand for low carbon energy technology. The second is improve access to affordable finance for everyone. And the last is amplify private sector committee to change. And actually all people, all the votes is on thinking on government policy and not the other. Thank you very much for your participation, your available information that we share with us. As Reina put on the chat, all the slides will be available in the ITU portal, and you have the link on the chat. Thank you very much also to all people that is listening us and if you have a question also in the future, please contact us, and we will be a pleasure to answer to all of you. Thank you very much.